Alright guys, hopefully everybody's doing well. Again, this is Mr. Esquivel here with the video for today. Again, hopefully it's the first of not too many videos. Sorry for the mistakes on the other ones. Again, I'm still working on learning how to do this more effectively. Again, I want to make these quick, so if you have any questions, please contact me. Also, if I'm going too fast, please pause the video, rewind, whatever you got to do to get the information. Alright, so again, hopefully everybody's doing well. Please contact me if you have any questions. So for my classes, we left off at 9.4, which was inscribed angles. We talked about the relationship between an inscribed angle and its intercepted arc. We said that if you have an arc that is 100, then the angle is going to be half. The inscribed angle is going to be half, which is 50, or vice versa. If you know the angle is 50 and it's inscribed, then the arc is going to be twice the size. Alright, so we did a couple examples, and then we left off here on top of page 15. Alright, so we're going to talk about inscribed polygons, and the first theorem that we have is if you know that you have a inscribed triangle, essentially, and the angle intercepts a diameter. So what this is saying is if you have an angle, in this case FGH, and the angle intercepts the diameter, which is FH, then you know that this angle is going to be 90 degrees. Angle G is going to be 90 degrees because the arc of a semicircle is 180. So we know that if the arc is 180, the inscribed angle is going to be 90. All right. So angle G is going to be half the arc FJH, so FJH divided by 2, right? That's what the measure of angle G would be, which is in this case 90, and FH is the diameter if this is a scenario. Alright, so that's theorem 10.9. For theorem 10.10, it's a simple one in regards to what we've been doing. And using prior knowledge, we can apply this here. Again, we talked about what a quadrilateral is. It's a four-sided figure. If you have one that's inside a circle, where all its vertices or angles are on the circle, then we know that the angles opposite to each other are going to be supplementary. So, if you know that you have a quadrilateral on the inside, all the angles are on the circle, then we can say that L and K and M are going to be supplementary. Again, if you refer to prior knowledge, supplementary angles that add to 180. Alright, so we can make two statements based off of this image. We can say K and M equal 180, and then you can say the other statement, which would be angle L and angle N will equal 180. Alright, those are the two statements you can say based off of theorem 10.10. Alright, so go and look at the first example. Again, this is related to theorem 10.9, which states that if you have an inscribed triangle where the legs of the triangle are intersecting the diameter, we know that this is going to be 180 degrees because that's a semicircle, so therefore the angle formed, the inscribed angle form is going to be 90, so angle L is 90 degrees. Based off of that, we can write an equation based on that simple fact. We can say that angle K plus angle M plus angle L is going to be 180. Again, that's a right triangle that we have. So then we can substitute the information in. So for example, now we have, we can say that 5x minus 4 plus 8x minus 10 plus the 90 that we have is going to equal to 180 degrees. So combining like terms, we get 13x, and then 90 minus 10 minus 4, that is going to be 76. And then I know you guys can use your algebra skills to find out what x is. Subtract 76. 13x equals 104. Divide x equals 8. But again, that doesn't answer our question. Our question is asking us to find angle K, so we got to use that information and plug it back into x here. So we want to find angle K. Measure of angle K is going to be 5x, or 5 times 8 minus 4, which ends up being 36 degrees. So we know what angle K is. Alright, if you want to find angle M, you do 180 minus 90 minus 36 to get the other one. Alright, the next example, we have example 5. We have a collection of stained glass ornaments, so that's what Lucas has, he's creating one. And he has an ornament that uses a quadrilateral inscribed the circle. So again, there's that word again, inscribed means it's inside and the angles are on the circle. So we can say that all of them are going to be equal to 360, but that's not necessarily going to help us out because if you take a look, you have y and x as variables for these angles. So then therefore we're probably going to have to use theorem 10.10, which states that opposite angles are supplementary. So let's just start off by doing F. We got to take a look at angle F and D. We can write a statement that both of them are supplementary. They add up to 180. So then we can now write our equation, which is going to look like 5y plus 16 plus 3y plus 4 equals 180. Combine like terms and get y by itself. Again, use your algebra skills to get y. Get y equals 20. Again, that doesn't answer the question. We have to find out what angle F is. So angle F is 3y plus 4. And we know that y is 20, so it ends up being 60 plus 4. So measure of angle F is 64 degrees. Right, so we know what angle F is, and if you want to find angle G, you would do something similar, but you would be looking at opposite angles, G and E, and you can write a statement, just like I did before. Angle G plus angle E, oh my muscles, look at that, equals 180. Alright, so you can write the algebraic equation. What is it? 3x minus 16, 3x minus 16, and we got plus x minus 4 equal 180. And I know you guys can solve that using your algebra skills. Alright, well, I'm going to wrap it up here. I want to keep you short. Again, if you have any questions, please contact me. Hopefully this works now with the audio. Otherwise, please let me know. But you wouldn't know. But anyways, yeah. Have a good day. Hope to hear from you guys soon.